Well, hello again. I have yet another viewer submitted puzzle today. I've been getting several of these recently, which is exciting. Um, this one is from Jeet Sampat. I think is how we're going to say that. Jeet Sampat, Jeet something or other. I apologize for the mispronunciation. But they sent this to me and said, I thought you might enjoy it. So hopefully I will. It looks very interesting. It does, just looking at the puzzle and the rules, I feel like it might be difficult, but we'll see. I don't know that. I really don't know anything about the difficulty on this one. But it is called Tokamak. Tokamak? I don't even know how to pronounce the title of the puzzle. But I Googled what that was, and apparently it is a device which uses a powerful magnetic field to confine plasma in the shape of a torus. And it's basically an idea that people are developing to try and do fusion power, which I believe some people think is, maybe impossible or impractical at least to do fusion as opposed to fission. Um, I don't know that much about it. Interesting idea. I think once we go through the rules, the reason it's called that will become clear. So rules. We have normal Sudoku rules apply. Clues. Excuse me. Clues outside the grid give the sum of the digits on the indicated toroidal diagonal. So these are little killer clues, and they're basically like normal little killers, except the 65, for example, this diagonal, it wraps around the grid. So you can see we exit here we're coming down and we're in row 5, so we enter in row 6 over here. And likewise, here, let's color that. We have like this 57. It's one cell, and then you come in here and it continues all the way around like that. And then it would wrap back around to itself. So, so that's where the torus, kind of like the Tokamak device. So that's going to be interesting. That's where I think it's going to be a little difficult, but we'll see. And then after that, we have normal stuff in cages, killer cages. The digits sum to the number in the corner. Arrows, the digits along the arrow sum to the number in the circle. So it's pretty standard constraints, other than the little killers are toroidal. So, that's it for the rules. I'm going to give it a try. Link in the description, as usual, if you want to try this out yourself. And we'll see how it goes. So let's start the timer. So, let's see. These are both 7s, but there's 3 ways that you can do 7 and 2. So we can't say for sure. What about this one? So there's 3 ways to do 8, but there's only 2 ways to do 6. So if we had 1 5. Oh, but this could be 2 6 or 3 4. No, no, not 3 4. That's 7. This could be, yeah. If that's 1 5, this can't be 1 7 or 3 5. This would have to be 2 6. If this is 2 4, this could be 1 7 or 3 5 then. I was hoping that maybe, since there's only 2 options for 6, that it would limit it to 2 options for 8, but I mean, we know there's a 1 and a, no, there's not a 1 and a 2, because you could have 2 4. There's a 1 or a 2, I guess, because you could have 2 4 and 3 5, so you don't necessarily even have a 1. Okay. Well, that's not very helpful then. All right, so we're probably gonna have to do something. I mean, so we know the arrows are all 6, 7, 8, or 9, right? Because they're 3 cell arrows, but they don't even. I mean, they could all be the same. They could all be 9 or 8 or so. Because they're not. They're kind of offset in different rows and columns. So it's gonna have to be the little killers. I suspect it's gonna be a combination of killers that's gonna do it. But let's look at, this is the smallest one. Now, one interesting thing about this toroidal thing, it's a hard word to say for some reason. All of the little killers are going to be 9 cells long. A lot of times you can have little killers where, there's only 2 or 3 cells if you get it kind of down here in the corner. But all of these are going to be 9 cells because they wrap around. So the smaller one and the bigger ones are definitely going to be likely the most important ones. All right, so 38. So let's see. This could be, but let's just put in but it's a small number. So normally you would expect to be limited by, you put in the minimums and see, but the minimums is going to be really small because this is going to be 1, 2. Well, that can't be 2. Okay, this has to be at least 6. So 6 and 1. 1. All right, I'm going to write those in just to keep track of it. These could be 1 and 2. This could be 1. These could be 1 and 2. Yeah, so this is going to be 3, 4, 7, 8, 9, 10, 16. I mean, that's not going to be helpful. And then on the other end, you're going to have, I mean, they're going to be quite big because you have 9 cells. And it can be 9 and 8, and 9 and 9 and 8, and 9 and 9 and 8 and 9. Yeah, so that would be 17 times 3 is 51, plus 27 is 78. But we have 7 degrees of freedom, so that's not that much help then, because, I mean, the 9s could be all the way down to a 2. The 8s could be a 1 even, theoretically. If you had a 9 and a 1, then the rest would have to be the maximums, but... Okay, so... Alright, let's see. I'm going to color the diagonals. Just to kind of see if anything jumps out at me, basically. See if there's any interesting patterns that form. Let's see. This one goes this direction. Now we're gonna get some overlap, but that's okay. We're actually in the CTC web app today, Cracking the Cryptic web app, and it will allow you to do multiple colors in the same cell. It kind of does a diagonal thing like this, which is pretty helpful on a puzzle like this. All right, let's go that one. Now, the trick here is, as some of you probably know, I am colorblind. So if I get too many colors in the grid, it can get confusing. So we'll see how this goes. This one goes here. Let's see, that one, I don't think I've done that color yet. And then one more. Okay, that one's going to be that color. So, now it's interesting. Of course, there's a regular pattern to this, which isn't too surprising, because all of these little killers are kind of rotationally symmetric, it looks like. So we've got duplicates in the middle. We've got duplicates kind of on these two, and then the ends of row and column 5. Now it's interesting, we've got these duplicates here and the ones in the middle, and they're all row 5 and column 5. And the other interesting thing is you'll notice these little killers, sorry, hitting the microphone. So these little killers do not cover the killer cages or the arrows, but they do get the circle. We also have some empty cells in the middle here, but so what can we do with that? So we know that these two sum to 90, but there's this double counted cell in the middle. So whatever's here would be, so it would be 90 minus this digit, essentially. will be all of these cells. And we know what these cages are. Now something else we could do. Hmm. I'm just wondering if there's something with the arrows here. Because the arrows aren't used currently, and the circles are double counted. Okay, let's go like this. Not that one. There we go. So I'm gonna make these three on the arrow gray, and then remove the gray from the circle. And so, because these three are the same sum as that one by itself, we can do that and still say the total of the gray is still 38. We could have done it the same way with the other color. Whatever this one is. I think it might be purple or blur purple. I don't know. Sorry, I'm bad with colors. But what that's done is it's taken away our duplicate there. Now we can't. I don't know how to get rid of this duplicate. But all right, let's just do that and see what we can find. So we're gonna do that, and I'm just kind of picking one of the two colors. Yeah, for now we'll just go with that. I don't know. This one, is that the right color? Yeah, there we go. And then over here we'll use the lighter gray. Okay, so now can we do something? Here's an idea. Okay, so um okay. I'm trying to think this through in my head while also trying to explain it. Um, so what we've done here, if you look, we've filled in, boxes 1, 2, 3, 4, 6, 7, 8, and 9 completely, if you count the killer cages as well. Right? We've filled every cell now since we filled in the arrows. And so we know, because we know, do we know? I don't know what we know. What do we know? Um, I feel like it's there. It's forming in front of me, this idea, but it's not quite. It's a little fuzzy still. Um, so because we know the total of all the diagonals, right? The problem here is, so if we just had if we didn't have any of these duplicates, and we didn't have anything in the middle. Let's imagine that was the case, which it's not. But imagine that was the case. We could take 8 times 45, because each box is 45. We could take 8 times 45. Right. That's what we're supposed to do. Okay. Okay. So, um, yes, 8 times 45. All right. I'm going to have to pull up. You know what? I'm going to pull up a little notepad window that I can type some notes in. Just a second. I'm going to pause and add that onto the screen for you here. Okay. So, now you should be able to see. Yeah. Okay. So here's my thinking. We've got 8 times 45, which gives us, what the total of all 8 of these boxes should be, right? Okay, which is going to be, what's 8 times 45? That's 360. So all of those boxes should be 360 total. So we can subtract the 4 cages, right? So if we subtract 28, that takes us down to 332. Equals 332. So we've got 332 for all of the colored cells We're not including these in the middle right now, okay? I'm hoping this leads somewhere. I guess we'll find out. So we have 332 should be the total of all of the colored cells in boxes 1, 2, 3, 4, 6, 7, 8, and 9. Now, if we add up all of the little killers, what do we get? Okay, we've got 260s, that's 120, 174, 239, 277, I hope, 277, 280, 330, 387, 388, 458. I think we get 458, which is too much, of course, because these are all double counted, and we're including these in the middle here. So those cells, okay, so these cells that are double counted, we have one copy of those, and then these four in the middle twice. All of that has to equal the 458 minus 332, which is 126. Because the diagonals altogether equal 458. All of these boxes should equal 332, so the extra ones, the double counted and the ones in the middle, have to equal 126. So let's try the maximums, and I'm hoping it will come out to 126. So let's see. If we did 6, 7, 8, 9 in the middle here, right? That would be 30, but we're doing it twice because they're double counted. Because there's two diagonals that hit each of those digits, essentially. Okay, and then can we have a repeat? Now, if these are 6, 7, 8, 9, then we can't repeat a digit out here. Because let's say you had two 9s, right? This 9 would remove 9 from there, and this 9 would remove 9 from there. There'd be no place to put a 9. So we'd have to have 6, 7, 8, 9 out here too. Now, if you changed one of these to a 5, for example, then you could probably repeat one of these. But these are double counted. These are single counted because we're just counting the overage on top of what should be in those cells already. And so by reducing one of these that's double counted in order to increase one of these that's single counted, I think you're going backwards. So I'm going to say that these are also 6, 7, 8, and 9, which is also 30. Yeah, this is going to work, isn't it? This is actually going to work. Okay, because that's 90. 126 minus 90 gives us 36, and what's left? 4 cells. 4 times 9, if those are the maximums, is 36. So those have to be, that's what it is. Those have to be 6, 7, 8, 9. These have to be 6, 7, 8, 9. And these have to be 9s. Wow. Okay. That was pretty insane. Hopefully it gets easier from there, because that was a crazy break-in, and I can't believe that worked. I thought for sure, about halfway through, I thought, this isn't going to work. This isn't going to make it into a video. This puzzle isn't going to make a video. Still might not. I don't know. We'll see. But I can't believe that worked. Okay, so now, right, now we have 6, 7, 8, 9 quadruple on both of these. Right, so the 7s can't be 1, 6. They both have to be, one of them has to be 2, 5, one has to be 3, 4, which gives us a 1 in the middle. And so that means this has to be 2, 4. It can't be 1, 5 anymore. And this can't be 1, 7 or 2, 6. It has to be 3, 5. Ah, interesting. So the other thing that we know now is these arrows So they can't be 9s anymore because we have a 9 in every one of those boxes. So these have to be 6, 7, or 8, which means they have to have a 1 on them. All of these arrows have to have 1s on them since they can't have a 9. Okay. All right. Do I want to remove the coloring or not? That's the question. That's the big question. Do I remove the coloring or do I leave it? I'm gonna leave it for now, but it might be a distraction, so I might remove it. All right. So now let's look again at. Yeah. So let's look again at the extremes, the 71 and the 38. Let's look at the 71. Since it's the biggest and the smallest, that's the ones that are going to be the most constrained, essentially. Because now we know, but this hasn't really limited anything. Because before it was, well, it has a little bit. Only because these can't both be 9s. And this can't be a 9. So this would be 8, 7. So we could do 9, 8... 8. These could be 8 and 7 in some order. 17 and 15 is 32. And 8 is 40. This could be 8 and 7 again. 57 and 8. 65. I can do math, I swear. Yeah, and then we could have... Oh, wait, that's wrong. Those are the wrong cells. Whew. Gotta look at the right ones here. Okay. So we had 40 over here. This could be 9, though. 49, 58... and 8 is 66, and this could be 9, so 75. So you've only got 4 degrees of freedom. So that's something. So like this one has to be at least 4. And these have to be at least 5. Because I was saying 9 was the maximum that could go in there. So that's a little bit of something. It's not much. Okay, let's look at the smaller one. Let's see if this gives us any help. This here. So the minimum we could do, because see, this one's going to be much more constrained because it has to be small, and we've already got 4 cells that have to be fairly big here. So the minimum would be 1, 9, 1, 6 and 7, 1. Oh, but this one can't be 1. Nope, I lied. Sorry. This can't be 1. It could be a 2. Because remember, the 1 has to be on the arrow here. So this one could be a 2 if this was, say, 1, 3, 4, right? Which would be 8. Actually, it can't be a 2 unless that's an 8, but it could be 1, 3, 4. So that's possible. Okay, so 2, 9, 1, 6, and 7. 1, 6, 2. Because remember, it can't be a 1 because the 1 is on the arrow. And then this could be also 2. Because again, can't have the 1. So that's 2, 4, and 6, 10, 11, and 13 is 24, 25, and 11. That's 36. So we only have 2 degrees of freedom there. So these could, we could still have a 9 here, but it can't be 9. It would have to be 9 and 6. Because the minimum is 13. So together they have to be 13, 14, or 15 at most. So you could have a 9 if it was a 9 and a 6. This 2, 3. This is 3, 4. 3, 4. So 2 degrees of freedom. Now which... But... I was hoping one of these other ones would cross that one. It doesn't cross... You know, like one of these other diagonals would cross this, and oh, it has to be a 3 or less, and then that would affect that diagonal. But none of them do. They cross here, but those aren't the ones that are being limited. And all these other ones are in between the 71 and the 38, so I don't think they're going to be very helpful because, I mean, the 53, they're all fairly similar in how they, they're all the same number of, they're all the same length. They all cross one of the nines that we got. So, like the 53 here, I mean, we could do 6 and 1 and 2, if we're looking at minimums, 7, 9. This would be 1 and 7 potentially because we can't repeat a digit. 9, 8, 17. Yeah, you're going to be 34, 1. Yeah. There's a lot of freedom there. So we know these have to be, they don't even have to necessarily have a 6 though, because they could be 7 and 8, which would also be, just our 2 degrees of freedom. It would force, let's see, if we force everything else to be minimums, are we gonna have any problems? If this is 2, 1, 1, 2, 2, these would be 2s. You have a 2 there. These would be 1s, which seems okay. Twos here, would put 2s down here. 6. Oh, does that even work? 6. We can't, no, we can't do that. Okay. Okay, here we go. This is the thing. We said this was a minimum of 2 and 6, but if this is 6, you have to have 1, 2, and 3 on the arrow. So this can't be 2 and 6, and it can't be 2 and 7. Does it have to be a 2 and an 8? No, it could be 6, 4, or 7, 3. Okay, but either way, these two, the minimum for these two is 8, right? That's what we were assuming when we did the minimums. But it's actually 10, because if you have 6, you have 1, 2, 3 on the arrow. This has to be a 4. If it's 7, you have 1, 2, 4 on the arrow. This has to be a 3. And if it's 8, you could have, well, if it's 8, you've used up your 2 degrees of freedom, and it has to be a 2 with a 1, 3, 4 on the arrow. So these two have to sum to 10. Therefore, the rest have to be the minimums. Okay. That's got to be helpful. And now this 2 means this can't be 6 or 7. This is 8, and it has to be 1, 3, 4. That one can't be a 1. This can't be 2, which means that can't be 5. Oh, the same thing up here. This 2 means this has to be 8, and it has to be 1, 3, 4. And this one, though, we don't really know. It could be 8, 2, 7, 3, or 6, 4. But 6, 7 pair in here tells us these are 8 and 9, which hopefully will help with something. Maybe the 60 diagonal. It goes across both of those. So now we know there's an 8 and a 9 and an 8, 9 pair here. So those are that's 34. So we need 26. This could be 8 and 7 and no, there's too much freedom there still. Okay. But we know 8, 8. So there's an 8 and a 9 over here. There's a 2 over here. There's a 1 down here. Okay, what else? What else can we do? There's not a 1 here. Down here on this arrow. Where can the 1 go? We know there's a 1 on the arrow. these two ones, see those, there has to be a 1 in the middle there, which gives us the 1 in this box, and that's not a 1. 1, 1. There's a 1 over here. Oh, but it has to be on the arrow. Right, of course. So it has to be right there. So we get all of our ones, I think. 1, 2, 3, 4, 5. Oh, almost. This one. Oh, this has to be a 1. So these two have to be 8 and 9. Because the 8s and 9s here has to be 8, 9 over there. So that's an 8, 9 pair. And now we've got 8, 9 pair in the row. So that's a 6 or a 7. These, oh man, come on. These 8s and 9s here, we've got 8, 9, 8, 9, row 4 and row 5. So the 8 and 9 in row 6 have to be in box 4. And the 9 actually has to be here because of the 2 9s there. Now the 8 is down there, but we don't know which one. Twos. Got a 3, 4 pair here. So these are 5, 6, and 7. That's interesting. This is also 5, 6, or 7. And these are 5, 6, 7, aren't they? Okay, so where do we look now? These can still be 8 and 7, which is what we were going with originally with our maximums. So I don't think that's helpful yet. We still don't know anything about these. I mean, other than what we already have here, these killer cages. I was hoping we'd get a like a 2 or this 2 here limited a little bit, but don't know. So these two have to be the same. Which puts 1 in the middle, and these two have to be the same. So, but all it tells us is that 3 and 4, one of them's in each column, but they could still even be in the cage there. So. What about 2 in box 7? The 2 here rules those out. It can't be in any of those. It has to be in one of those 2. The only way it's not on the arrow is if it's 8 with a 1, 3, 4. Otherwise, the 2 has to be on the arrow. But I think it could still be 1, 3, 4 with an 8. I'm not seeing why not yet. But the 2 here means that's not a 2, which means this one is not an 8. And the 2 has to be on this arrow, which has to be there because of this 2. So 6 is either 1, 2, 3 or 1, 2, 4. So this is a 3 or a 4. Giving us another 3, 4 pair. These are 6, 7, and 8. So there's a 9 in there. There's actually a 9 in all of these kind of outer areas. 9 here, 9 there. So in column 4, the 9 has to be down here, which puts it right there. So there's a 9 in one of those 2. Because we know there's a 9 in one of these 4 outer cells. Okay, so this is 1, 2. This is either right, because it's 6, 4, which would put a 3 there, or a 7, 3, which would put a 4 there. So either way. Oh, but the 2 here gives us a 4 and a 2. And that 4 gives us a 3, which means this is a 7, and this is a 4, which gives us the 3 and the 4 and the 3 and the 4. It's just bouncing all over the grid. The 4 here means that's not a 4, so that can't be a 3. 3, 2, 4. Oh, but it could still be 2, 5 or 4, 3. This one can't be a 2, so that can't be a 5. This is not 4, that's not 3. And again, 5, 2, or 4, 3. This has to be 2 or 4. Oh, it could be 5, actually. You could have 1, 2, 5 with the 8. But it can't be 1 or 3. It could be 2, 4, or 5. This one can't be 1 or 4 or 2, so it's 3 or 5. So if it's 6, it's 2, 3. If it's 7, it can't be 7 because it would have to be 2, 4, but this can't be 2 or 4 down here. So it can't be 7. 8 would have to be 2, 5, or 3, 4. So this one can't be a 5 up here, actually. Because for this to be a 5, it has to be 1, 2, 5, which would force a 2 down here. But this could be 3, 4, 2, 5, or 2, 3. But there's a 2 over here, isn't there? Yeah, there's a 2 right in one of those cells. Because of the 2 here and the 2 there. There's a 2 over here. Okay, so... Oh, these can't be 7 anymore. These can't be 7. What else can we do? 3, 5, 4, 2. Oh, the 3 here gives us the 5 and the 3. So this is not 5. This is not 5. Now, there's a 3 down here. A 3 in one of these two, actually. Because that 3 and these 3s. Versus a 3 in there. There's a 3 in here. There's a 3 somewhere in here. That's not very helpful, is it? 8, 9. These have to be... Yeah, that could be almost 8. There has to be a 6 or a 7 and an 8 or a 9. But that could kind of go either way at this point, I think. Let's see, what about the 8 down here? Can we do anything? No, I feel like the 8 could be in a lot of places still. Okay, so I think we need to look at the little killers again. Which one do we look at is the question. So we've already used the 38 is taken care of. We've used that one. Should we look at the 71 again? Excuse me. It goes through here. All right. I think I'm gonna delete the colors. They've been in there a long time, but I think it's just gonna make it easier to look at the diagonals we want to look at. Okay, I'm just gonna highlight the 71 diagonal. So, we've got 8. So the maximums would be 8 and 7. Oh, this can't be an 8 anymore because of that 8. Should have seen that. So let's say 8, 7, 7, 8, 7. So that's 37 and 9. 37 and 9 is 46. And 17 is 56, 63. And this could be 9, which would be 72. So that only gives us 1 degree of freedom. Okay, so these were 8, 7, so they could be 8, 6, potentially. This can't be a 4, because we only have 1 degree of freedom. These we said 8 and 7. So again, 1 degree of freedom. So it could still be 6, 8, but this one can't be 6, can it? This is an 8. This is an 8, because these two together were 8 and 7 were 15. So they can only be 14 or 15. And this one can't be a 6 because that one can't be an 8. Right. Okay. So that's the 8. 8, 7, 9. And this one has to be an 8 or a 9. And we know one. No, that's our degrees of freedom. Yes. So we were saying both of these as nines, right? Using the maximums. But actually, they can't both be nines because we don't have 9 as an option in either of these. One of these two has to be a 9. Therefore, one of these two has to be an 8. And I think that's our degree of freedom. So that would be 17. 17, that's 34. This would be 15 and 15 and 7. So we'd have 34 up there. We'd have 37 here. 34 and 37 is 71. So these are essentially an 8-9 pair here. The 7 down there, the 7 up here gives us an 8 there because we know they have to be 6, 7, 8, and 9 here. Because we can't have two 7s here or you rule out both the 7 options in the middle. This is not 7 or 8. This is, oh, the 8 here. Yep, 9. 8 gives us 9. Oop, hit too many buttons. 8, this is 9. That has to be 6. And now we're really making some progress. The 5-8 pair there gives us a 7 there and a 6 there. This is not 6 or 7, so it's a 5. That's a 6. These are not 6. The 5-7 pair gives us a 6 there. That 7 gives us the 5 and the 7. This is a 2 or a 4. I'm going to get rid of the colors. It's just distracting. Okay, the 6 there gives us an 8 here. So this has to be 2, 5, or 3, 4. It still has a couple of options there. But this is 2, 3, or 5. There's a 6 up here. Oh, the 8 there. 5 and 8. Okay, what do we need in the middle here? These are 1, 2, 3, 5 and 7, right? This one has to be the 5 because of the 7 down here. And these are 3 and 8, and the 8 there gives us the order. Now, let's look over here. Do we know anything more here? I don't. So 3, 5, or 6. And these are 2, 4, and 7. But the 7 has to be at the top. 7, 2, 4. Okay, let's see. What do we have left in here? 2, 4, and 6. This one can't be 4 because of the 4 there. This one can't be 2 because the 2 over here. So there's definitely a 6 in there. There's a 6 up here, right? Yeah, we can't have 6 in any of those. So there's a 6 up here, which means this is not 6. So that's the 6 down there. 2, 3, 4, 5, 6. Okay, these are 2, 3, 4, and 5. These can't be 3. And these can't be 5. Do we know anything more than that? I don't think we do. Okay, so we've used the 71. We've used the 38. Which one should we look at now? Maybe, yeah, this one right here. Because it's only got one cell left. Or 2 cells, I guess. Sorry, it's got 2 cells left. But we've got 15 and 15. That's 37. 45 and 8 is 53. So we need 7. So these two have to sum to 7. So this has to be either 3 or 5 to go with the 2 or the 4, which gives us a 3, 5 pair. That tells us this is a 4 or a 6 here. 3, 5, 2. This is a 2 or a 6. So we have 2, 4, 6 here. 2, 4, 6 triple, which makes this one a 5. And now we finally know the order of our 7 cages here. So 3, 4. These are not 4. This is not 2 or it's not 3 or 5, so it's a 2. Because it's a 3 and a 5. 2, 4 pair gives us a 6 here. That 3 gives us the order of the 5 and the 3. And then 2, 6, 2, 4. Okay, now we got to use the diagonal to finish the end here. Which one should we use? Which one should we use? Let's see. Well, we can use the 57. There's probably multiple ones we could use, but that's 15 and 7 is 22, and 3 is 25, and 15 is 40, and 11 is 51. 57 is our total, so that makes that a 6, 4, 2, 4, 2, 4, 2, 6. Looks good to me. Timer stopped. Now, this one does not have, the Cracking the Cryptic app does not have the solution in here. It's just looking for normal Sudoku rules. So, for example, let's see if there's a good spot. Yeah, right here. If we change this to 3-8 and 8-3, it says looks good to me, which clearly this arrow is a problem. So, I'm pretty confident that's the solution. I'll go through and double check all the little killers that they sum to the right amounts and everything, but I think that should be right. And there you go. That's the solution to Tokamak. Tokamak. I'm not entirely sure how to pronounce it. I should have probably looked that up, but you know, that's all right. I like mispronouncing things. It's fun. Gives people something to correct me about in the comments. Hopefully you guys enjoyed that puzzle. I actually think 43 minutes is really good. I'm happy with that. I feel like I kind of got lucky with that break-in because I just kind of tried the right thing, I guess. I really didn't think it was going to work, and it did. That was pretty amazing how you had to... You not only did you have to use all of the little killers, but then you had to kind of change one of the circles to be the arrow digits. There might have been another way to do it. If you found another way to break into it, let me know. I'd be interested. That seemed to work. And then I almost blew it over here with the 38, thinking you could do 2 and 6, which you clearly can't, because 6 has to have 1, 2, and 3. But, yeah, so there you go. That was Tokamak. Hopefully you guys enjoyed that puzzle. Let me know what you thought, and I'll see you again soon with another one. Thanks.